The term dark matter is a placeholder for matter that we're almost certain must be out there because we see the effects of its gravitational pull. But that's all we see, so we don't know exactly what it is yet. There are a lot of competing explanations, and one of them has raised a few eyebrows recently because it could account for some unexpected experimental results. Maybe most interesting of all, this dark matter candidate opens up the possibility that there are ghost stars out there in space. I'm talking about dark bosons, hypothetical subatomic particles with a very low mass. In the most widely accepted explanation for quantum phenomena, the standard model of particle physics, bosons are force-carrying particles like photons and gluons. They're a different category from fermions like electrons, protons, and neutrons, and they play by different rules. While fermions have mass, bosons can have mass or be massless. Fermions also obey the Pauli exclusion principle, which states that no two fermions can occupy the same quantum state. This means that fermions, like electrons, can't be in the same place with the same spin at the same time. That's not true for bosons, which means several identical bosons can be packed into the same spot. Because they can have mass and occupy the same space, it's possible that lots of dark bosons could gravitationally attract each other and create an object with a mass comparable to a star. A so-called boson star would behave very differently from the stars made up of ordinary matter that we're used to. They wouldn't be capable of fusion, so they wouldn't be able to produce any light. Actually, they should be totally invisible, since light wouldn't interact with the particles and instead would just pass straight through them, hence the ghost star moniker. Although a ring of plasma could form around them and give them away. They could become incredibly massive as the supermassive black holes that are at the center of most galaxies. Some scientists have suggested that a boson star is actually what's at the center of our own Milky Way. A hypothetical dark boson could solve the big mystery of dark matter, namely how it exerts a gravitational pull while remaining otherwise invisible. But of course, a question this big can't be put to bed without a mountain of evidence, and for dark bosons there is, at best, a little bitty pile of dirt. Still, it's something, and some of that possible evidence came very recently from some big-name experiments. One of them is the Xenon 1T experiment in Italy. Xenon 1T is a big tank of liquid xenon inside an enormous tank of water buried under a mountain. It's actually looking for an entirely different dark matter candidate called weakly interacting massive particles, or WIMPs. Last summer, though, the scientists examining data from the experiment announced they saw an excess of electrons that WIMPs couldn't account for. It's possible dark bosons interacted with the xenon, which would explain what the detectors picked up. But so could a more mundane event, like radioactive contamination, in the experiment. Another big-name experiment that could be pointing to dark bosons is Ligo, the interferometer that famously helped detect gravitational waves from the merger of two black holes back in 2015. Researchers noticed that one of the many collisions it has since detected was unlike the others. It was missing an initial stage where the two black holes spiral around each other. The scientists calculated if two unconnected black holes could achieve this with a head-on collision, but the math didn't work out. When the researchers substituted boson stars in place of black holes, though, things clicked. Still, we are a long way away from calling this case closed. Maybe other explanations can better account for the odd results from Xenon 1T and Ligo. Or maybe these detectors, and more advanced ones in the pipeline, will produce more evidence of dark bosons. Dark bosons might not be the end of dark matter either. Remember, bosons are force-carrying particles, so maybe they're not dark matter itself, but the way regular matter interacts with some other particle that is dark matter. There are still so many question marks, but the thought that there may be massive ghost stars out in space that we have yet to see is a nice reminder that there is still so much to discover and search for. Xenon 1T hasn't conclusively found dark matter, but it has seen something else incredibly rare. If you want to find out what, check out my video on the experiment here. Make sure to subscribe, thanks for watching, and I'll see you next time on Seeker.